Welcome to 6.6a video lesson in Algebra 2. There are 5 boxes here. The concept here is function operations, adding, subtracting, multiplying, and dividing. So here is box 1 for you. This looks intimidating, but this is not really a big deal because I think we talked about this a little bit. I think I introduced it in Algebra 1 for some of you. For function composition, for function operations, we have 4 main operations, just like we do in regular mathematics. We have addition, subtraction, multiplication, and division. So what we're going to do is we're going to assume that we have 2 functions, f and g. And if we want to add f plus g of x, it is the exact same thing as taking f of x and adding it to g of x. Okay, so we are allowed to add the individual functions separately. Same thing for subtraction. I can take f of x and I can subtract off g of x, right? If I want f times g of x, it's the same thing as f of x, well, just times g of x. It's exactly how you would expect it to behave. And division, if I want f divided by g of x, it is f of x divided by g of x, everywhere that g of x, of course, is not allowed to be a 0. So if I want to take f plus g of x, it's the same thing as multiplying or as adding individually. If I want f minus g of x, it's the same thing as subtracting individually. F times g of x is the same thing as multiplying individually. And f divided by g of x is the same thing as dividing individually, provided that g of x is not 0. So these are the key concepts, and I'm going to be working with these throughout the lesson. Hopefully this is not a major review for you. Okay, let me show you 2 examples here in box number 2 for adding and subtracting functions, and then let's also talk about their domains at the end. So let's say I have the function f of x is equal to 5x plus 3, and let's say I have g of x is equal to the square root of x plus x. The first thing that I want to do, since I know I'm going to be talking about the domain, is I'm going to find the domain of each individual one. So the domain for f of x is all real numbers because that's just a line, and we know that that's all real numbers. The domain for g of x, though, is I have to pay close attention to this part because this part is going to tell me that every x needs to be greater than or equal to 0, but this part is just all real numbers. So then the part that they have in common, the domain for g of x is x needs to be greater than or equal to 0. And the domain for f so far is just all real numbers. So let's just keep that in the back of our minds as we're working through this problem. So part A says, what is f plus g of x? And then, of course, find the domain. So we learned in box 1 that f plus g of x literally just means f of x plus g of x. And f of x is right there. It's 5x plus 3, so 5x plus 3. And g of x is right there. It's the square root of x plus x. So if I simplify this, I get 5x plus x, that's 6x plus radical x plus the number 3. So if I look at this now, and then I ask myself, okay, what's the domain of that? The domain of that is going to be all real numbers x such that x is greater than or equal to 0, because I have to consider that piece right there with the square root, and we want to consider the what's true for all variables in the function. So therefore, the domain has to be restricted to everything that's greater than or equal to 0. Let's do part B. Let's find f minus g of x, right? So again, this literally just means f of x minus g of x, okay? F of x was 5x plus 3? Yes, 5x plus 3, okay? And then minus, now g of x is the square root of x, and then I think it's plus x, yes, plus x. So look how I have a bracket after my minus sign to remind myself that everything to the right of the minus sign is negative. So I'm going to use the distributive property here. And this is going to tell me that I get 5x plus 3 minus the square root of x minus x. And this is going to simplify to 4x, because 5x minus x is 4x, minus root x plus 3. And again, when I consider the domain of f minus g of x, it's going to be the same thing, all real numbers x such that x is greater than or equal to 0, because I have a square root in my expression. So this is where we're going, and hopefully this makes sense so far. Okay, here's box 3, here's a u-try. Let's say that f of x is 2x squared plus 8, and let's say that g of x is x minus 3. I want you to find f minus g of x. Just do this part first only. Okay, for the first part here, hopefully you got that f of x minus g of x is just 2x squared plus 8 minus the quantity of an x minus 3. So that's 2x squared plus 8 minus x and then a plus 3 when I distribute that sign. So I got 2x squared minus x plus 11. Now, I want you to tell me the domain for f minus g of x. Basically, what's the domain of this expression that I have in the box? Okay, hopefully you got all real numbers because this is a quadratic. All this is a parabola that opens upwards. Therefore, any real number can be plugged into it. So therefore, the domain of this function is going to be all real numbers. All right, let's move on to multiplying and dividing two functions here. So let's say that I've got f of x is 3x squared minus 11x minus 4, and g of x is 3x plus a 1. What is f times g of x, and then what's the domain afterwards? So we now know that f of x times, or f times g of x is just simply f of x times g of x. So that's going to be 3x squared minus 11x minus 11 times the 3x plus 1. I'm going to go ahead and use a box method for this one because I don't want to mess this up, all right? So I'm going to use a box method for this, and maybe you guys are familiar with that. So I'm going to put 3x squared minus 11x and then a minus 4. And then I'm going to do a 3x and then a plus 1 over here for you, okay? I'm going to multiply everything inside the boxes. So 3x squared times 3x is 9x to the third. This is negative 33x squared. This is a negative 12x. 3x squared times 1 is a 3x squared. This is a negative 11x, and this is going to be a negative 4. So when I put all of my terms together, I get 9x to the third. That's this one. So 33x squared plus negative 33x squared plus 3 is going to be a negative 30x squared. So that takes care of these two like terms. And then I'm going to have a negative 23x. That takes care of these ones and these ones. And then a minus 4. So this right here is nothing more than a third degree polynomial. And the domain of this thing, of course, is just all real numbers because any polynomial has a domain of all real numbers for that. Okay, now let's do part B, and let's do what's f divided by g and what's its domain. So again, we're just going to take f of x, and we're going to divide it by g of x. So f of x is 3x squared minus 11x, and then a minus 4, and we're going to divide this by g of x, which is 3x plus a 1. So now we're going to try and factor the numerator here. We're going to try and factor the numerator and see what we get. And of course, the denominator is just a 3x plus a 1. So the only factors of 3x squared are 3x and x. And then the factors of 4 are 1, 2, and 4. So let's try a 1 and a 4 here. So 12 and 1, yeah, I can make an 11 out of a 12 and a 1, provided that this one would be negative and this one would be positive. So therefore, I would get back just an x minus 4, because that cancels out. So that would simplify to x minus 4, but the domain is going to be everywhere where g of x was not equal to 0. So the domain of this thing is going to be all real numbers x, such that x is not equal to negative 1/3. And all I did to do that was I solved this little guy for what values of x that it can't be. So even though it cancels out, it's still a member of it's still not allowed in the domain. So keep that part in focus when you're doing the division parts here. So the expression is x minus 4, but the domain is everything except for negative 1/3 because it is a member of the g of x, which is in the denominator there. Okay, tough example, but hopefully that made sense to you. Okay, box 5, last one. This is a u-try. So let's let f of x be x squared minus 9 and g of x be x plus 3. I want you to perform f divided by g of x and then tell me the domain. All right, so hopefully you got the real answer here. The expression is x minus 3 when I take f of x divided by g of x. But the domain is every real number x such that x is not equal to negative 3 because, again, I cannot allow any x variable to be in the denominator that produces a 0. And since a negative 3 will produce a 0 in the denominator, it is restricted in the domain. Even though it cancels out, it's still part of the domain. So hopefully that made sense to you, and we will practice more in class tomorrow.